Okay. In our previous video, we had seen with the class full addressing. So class A network, class B network, wherein the number of networks is to the power of 14 and number of hosts is to the power of 16. Okay. Class C, which has many number of networks, but however, the number of hosts within a network can be only 256. Right? This is for a mediocre type of organization wherein you have 64K hosts and you have sufficient number of networks. Okay, and class D is multicast addressing, class E is reserved. Remember one thing, these network numbers are managed by a non-profit organization which is called as ICANN, which stands for Internet Corporation for Assigned Names and Numbers. Okay, so if at all you want to have an IP address, you want to purchase an IP address, you have to produce the necessary documentations, how many hosts you need to you will have within your organization, and how many networks you will have, etc. and etc. to this particular organization. Only then you will be allocated with the IP addresses. Okay, so the network addresses again which are 32 bits are usually written in a dotted decimal notation in this particular format. So you have 128.208.2.151. So in this format, each of the 4 byte is written in a decimal format from 0 to 255. Right? So you have few special addresses, like if all the bits are 0, right, it means it is this host. Right? So if at all you have a network bits as 0 and some numbers in host part, then it means a host on this network. If all bits are 1, it means a broadcast on a local network. If at all you have some network address, but however you have all ones, it means broadcasting on this particular network. Okay, and if at all you have first octet to be 127, it means and anything followed by it is called as a loopback address, wherein that particular packet will not be put onto the interface. We usually use such addresses for testing purpose. For example, you have developed an application. Now you want to see how the client should respond and how the server should respond. You basically do not put that packet onto the interface. You test the client and server machine on a same host by making use of loopback addresses. Okay, and the IP address, that is 0.0.0, is used by the host when they get booted up. Okay, yeah, this is just a description of whatever I just explained to you. Right, now let us see an example of how the addresses gets converted and what are the technical terms used over there. So if at all you have an IP address of 172.16.18.106 and 79.73.236.63, their respective hexadecimal and binary format will be somewhere like this. So each of these decimal numbers, that is 172, 16, 18, these are called as octets, right, because you can represent them in 8-bit format. So each of them will be represented with a number. So 172 is nothing but in hexadecimal it is A and C. So you can just check it if at all there is some confusion. Okay, yeah, the binary form of it is 172, right, in binary, 16 in binary, 18 in binary, and 106 in binary. Similarly, 79 is 4F, 73 is 49, 236 is EC, and 63 is 3F. Right? Similarly, the binary representation for the same is this. You have to become very much perfect of this representation in hexadecimal form as well as the binary form. The binary form is important because when we deal with the subnetting and subnet mask, you have to remember how many bits of ones you have, how many bits of zeros you have, right? Okay. So let us see how it looks through an interface. So you have a machine of 209.165.200.255, sorry, 225, and it is connected to a router with three interfaces. At one of the interface is your switch, and at other interface you have one more switch, and the IP addresses over here are 192.16.10.1, and for this you have 192.168.11.1. okay. Now if you look at the network address of LAN A and LAN B, you have something something to look into it. You have something like this: 192.168.10.0, okay, 162.168.11.0. So one thing is that the network addresses always have the last octet as 0. Here also you can see last octet as 0. However, the host, they are numbered sequentially, right? So if you just look at over here, your one of the desktop machine, it has the IP address 192.168.10.10. The network part remains the same, that is 192.168.10. However, the host part, we shall see shortly what do you mean by network part and the host part, it varies, that is 10. Here if you observe 192.168.11.10. Clear? So this is basically an interface of a router. So how many interfaces does it have? It has 3 interfaces. Interface 1, G0/1, G0/0, and this is one more interface, third interface, right? So we do not assign any IP addresses to the switches because they simply broadcast the frame that comes to it, right? Okay. So the same thing I have just represented in terms of binary. Okay. Now contrasting desktop machine 1 IPv4 dotted decimal format and its binary number. So octet 1 is 192, octet 2 is 168, octet 3 is 10, octet 4 is 10. So IP address is made up of 4 octets. Each of these octets, okay, they are represented with 8 bits. Hence the term is called as an octet. So 192 represented in 8 bits, 168 represented in 8 bits, similarly this. So what is the maximum value you can have? It is 2 to the power of 8, which is 256. However, we have from 0 to 255. 256, it is again it takes 9 bits to represent, 1 followed by 8 zeros. So the maximum value, all ones, it is nothing but your 255. Okay, so each octet can have the value from 0 to 255. Understood? Alright. Now we shall see with what constitutes your host part and what constitutes your network part. So IPv4, as I was telling in the previous video, it is hierarchical, which is made up of network portion and the host portion. So when determining the network portion versus the host portion, it is necessary to look at the 32-bit stream of addresses. So within this 32-bit, a portion of bits identify the network and some portion of bit identify the host. So for a particular network, the network part remains the same, only the host part varies. The host will get a different IP addresses, okay, belonging to a particular network. This differentiation is important because your router will forward the packet to a particular network. Okay. Yeah. Let us take an example wherein you have the last 8 bits representing the host and 24 bits representing the network. So this is typically a class C network. We have discussed when I was discussing with class full addressing. So you have 192.168.10 which represent the network part, and the host part is the last 8 bits, right? So the bits within the network portion of the addresses are identical for all the devices that reside in a same network. The bits within the host portion uh, are unique to identify a specific host within a network. So if two hosts have the same bit pattern in a specified network, those two hosts will reside in a same network, right? But the question is, how will a host know which portion of 32 bits identifies the network and which identifies the host? That is, how to differentiate between the host part and the network part. Here is your subnet mask, right? So basically a subnet mask, uh, it is used to understand what is your host part and what is your network part. So here is a clear definition of it. A subnet mask is used to identify the network or a host part of the IP addresses, and the default gateway identifies the local gateway, that is a local router interface to each in order to reach to the remote networks. So if you have configured a host, you typically open up this window and you give the various things over here: the IP addresses, the subnet mask, okay, the default gateway, etc. and etc. This is what I mean. Why should we give the subnet mask? Is in order to classify the host part and the network part. Okay. So when IPv4 is assigned to a device, the subnet mask is used to determine the network address where the device belongs to. This is specially required for your routers. However, even the host need to know what is the network part and what is the host part for the destination IP address. We shall see it shortly. Okay. So the network address represents all the devices on the same network. So it is something like this. If the subnet mask is something like this, 255.255.255, it is 8 ones followed by 8 ones followed by 8 ones, and a 0 for the last octet is 0. Now whenever we write this IP addresses along with the subnet mask, there is some shortcut method of writing this. What we do is we write it in a prefix format, that is slash notation. It is written as counting the number of ones. Here we have 24 ones, so this subnet mask is written as slash 24. So it is a it's discussed over here. Okay. To identify the network and the host portion of the IP addresses, the subnet mask is compared to the IP addresses bit by bit from left to right. The ones in the subnet mask identify the network portion and zeros identify the host portion. Okay. So this is a note wherein the subnet mask actually does not tell what is the IP address of the machine. It is just used to differentiate between your host part and the network part. Okay. So your IP addresses and your subnet mask. So when you perform an AND operation, it will keep your network part as it is, but however your host part goes to 0. So basically when you perform an AND operation with IP address and a subnet mask, what you get is the network address. Okay. We shall stop this video till here. In our next video, we shall see how to determine the network address.